All right, so as you can see, we're going to be working on systems of linear equations. Today, we're working on elimination. One of the three methods. Now, you guys have already done graphing at this point. You've done substitution, so it's time to move on to elimination. Let's see what it looks like. So here's our elimination problem. And elimination is exactly what it sounds like. You're going to eliminate one of the variables by adding the equations together, subtracting the equations together, something like that. So our system is x minus y equals 11 and 2x plus y equals 19. If you look at this as it is right now, you should be able to tell that if you add the two equations together, you're going to have this negative y here and this positive y are going to cancel each other out, thus eliminating the y variable. So if we did that, and we add the equations together, we're going to end up with 3x is equal to 30. And then solve it just like you would solve any other equation. We would divide by 3, and you find out x is equal to 10. Now, at this point, most of you are going to go back and you're going to substitute in x equals 10, which is the quickest way, and you will find out what y is. So let's do that first. We'll take one of the equations. Let's say, let's take the x minus y equals 11. I'm sorry, equals 11. And we'll substitute 10 in for x. So we have 10 minus y is equal to 11. And then we'll subtract 10 from both sides. And we'll see that negative y is equal to 1. And divide by negative 1. So our y is equal to negative 1. And our solution to this system would be x is equal to 10. And y is equal to negative 1. But like I said, we used substitution for the second part. So what I'm going to do is I'm going to show you how to do something with what we call true elimination. Meaning we eliminated the y to find x. Now we're going to eliminate the x to find y. So our two equations, x minus y is equal to 11, 2x plus y is equal to 19. And now what we want to do is we have to get to the point where we have the same coefficient for x, but maybe different signs. So what you should be able to see from this is if I multiply this top equation by negative 2, that equation is now going to be negative 2x plus 2y is equal to negative 22. Right? Again, that's just distributing our negative 2 to everything in the parentheses. And the bottom equation will keep the same. So it's 2x plus y is equal to 19. Now, remember, when we multiplied everything in this top equation over here by 2, we haven't changed the value of anything. Because what we did to one side, we did to the other side. So it's still the same value. It still has the same equation. It's still, the variables would still be the same. So now we have our two equations, but we're able to eliminate our x term this time. Because again, if you look at it, we're going to have our negative x, our negative 2x rather, and our positive 2x are going to drop out this time, thus eliminating the x variable. And then we would have 2y plus y is equal to 3y. And negative 22 plus 19 is negative 3. And then divide both sides by 3. And we would find out that y is equal to negative 1. Just like we found out before. So that would be true elimination. So let's try this with another problem that's not already set up to eliminate. Okay, so here's another problem, and let's look at this one for a second. You should see that right now, if I added these equations together, I'm not going to eliminate anything. If I subtracted these equations from each other, I'm not able to eliminate anything. So I'm going to have to modify one of these equations. So just like we did in the last problem when we did true elimination, we're going to have to find something that we can do. And there's a couple things we could do. The easiest thing to do is going to be to take this top equation and multiply it by negative 3. Now look at it and see if you can figure out why I'm going to use negative 3. Right, because negative 3 times y is going to give me negative 3y. And I already have a positive 3y here. That will let me eliminate the y variable. So let's multiply everything by negative 3. I would get 21x minus 3y is going to be equal to positive 57. And on the bottom, the equation stays the same. So I have 2x plus 3y. I'm sorry, it's negative 2x plus 3y is equal to negative 19. Now, if I add these two equations together, I'm going to get 19x, and again, my negative 3y and positive 3y, those are going to drop out. I'm eliminating the y. And that's going to be equal to 38. And then divide both sides by 19. And x is equal to 2. So, now I know x is equal to 2. Come over here, and I can put my 2, comma, and then just figure out what y is. And again, we can substitute back in. You guys know how to do substitution, so I don't have to go through that again. But I'm going to set it up again so we can eliminate. This time we want to eliminate the x variable. So how are we going to do that? Well, this problem not that easy. So if you look, I have a coefficient of negative 7 in one equation. I have a coefficient of negative 2. They are not compatible numbers. So what I'm going to do is I'm going to multiply both equations. So I'm going to multiply the top equation by the coefficient of the bottom one. So I'm going to multiply the top by negative 2. And I'm going to multiply the bottom one by the opposite of the coefficient of the top one. So I'm going to multiply this one by positive 7. So what that's going to do, well, you'll see what it's going to do. So I have negative 2 times negative 7 is 14x. Then I have negative 2 times y is negative 2y. And that's going to be equal to positive 38. Then I have negative 2x times 7 is negative 14x. So there you can kind of see we're going to eliminate the x. Then I have 7 times 3y is going to be positive 21y. And that's going to be equal to negative 19 times 7 is negative 133. Okay, so now let's put them together and see what we get. Well, hopefully you could see that our x term is going to eliminate, right? So that's going to go away. Then we're going to end up with 19y, right? Negative 2 plus 21 is 19y. And then I have 38 minus 133, which is negative 95. And then divide both sides by 19. So y is going to be equal to negative 5. So our solution to our system is 2 and negative 5. Now, we didn't do this on the first one, but if you want to check this, very simple way to check it. You substitute 2, negative 5 into both of the equations. So if I did it for the first equation, I would have negative 7 times 2 plus negative 5 should equal negative 19. And that gives me negative 14 plus negative 5 is negative 19, which is negative 19. So that works. And then if we check the other equation, I'm just going to make a little bit of room over here. If I check the second equation, I should end up the same way. So I have negative 2 times 2 plus 3 times negative 5 is equal to negative 19. So negative 4 plus negative 15 is negative 19. And negative 19 is equal to negative 19. So that problem checks. And again, when you look at this, you should be able to see that elimination is probably a little bit easier than substitution in most cases. But there are some cases where substitution is easier. So this is really where you have to use your math skills, that acquired knowledge that you have over the years of knowing which is going to be the best method for me to solve this system of equations. I can tell you as a math teacher, generally speaking, when I give an assessment on systems of equations, I give the kids 8 problems to do. 2 of the problems are going to be graphing. 2 of the problems they're going to have to use substitution. 2 problems they have to use elimination, and 2 problems they get to pick whatever way they want to do it. I want to make sure they know all 3 methods, but I also want them to be able to determine what the best way is to do the problem. Okay, thanks for watching. I hope this helped.